Hey, what's going on, guys? Welcome back to my channel and welcome to chapter 4 of my course on cross origin resource sharing. And in this chapter, I want to talk about CORS finally. And I'm going to discuss it in a couple of chapters, but this particular one, titled Course Basics on the Client Origin Header in brackets. So basically, what's going to happen in this course, in this chapter, is a few things as I've listed here. The first one is we're going to have a little recap. I know that will be a bit of a repetition, but it's very, very important for us to keep things in context. And it will, I believe it will serve for better understanding. And then we're going to do a demo using Spring Boot and React. Okay. And then in the demo, we're going to see specifically what happens when cross origin request is sent from a script to a server. And then we're going to look at some two options of resolving the course errors that we're going to encounter. One of them is disabling calls, which is not recommended, but it's good to understand the option. It might help in some other scenarios. If your needs uniquely don't really care about calls, you can disable it, and we're going to be able to see the side effects of that, and you can decide if you're good with them. And the second option, so the two approaches are disabling CORS, as I mentioned, and the second one is opaque responses. So, and then we'll just do a summary of the chapter. So basically, just flow with me here, and let's go to the recap. So, CORS, cross-origin resource sharing. As we looked earlier in previous chapters, we saw that the internet is a vast amalgam of multitudes of computers. Some are servers, some are clients. And we also looked at the fact that web applications typically don't run in silos, they depend on each other. And a client application, maybe a React app loaded on the browser, may depend on third party servers. And when some of the resources it downloads from these third party servers are scripts like JavaScript files, then the fact that those scripts are downloaded from a different origin, as we defined, they and they attempt to make requests to our own server, then these requests are considered cross-origin requests, and they are by default not allowed because of the same origin policy. So the same origin policy dictates that requests from scripts in browsers must be from scripts that were originated from the same server that they are calling. Okay, so the fact that we have all these benefits of cross-origin resource sharing, where we might enrich a user's experience by pulling resources from different third-party servers. We saw value in this, right? But then we also have the risky aspect because we might download malicious scripts that do something we don't like on the server. So on the one hand, we have the value of cross-origin data exchange. On the other hand, we have the dangers and the risks. So we have this catch-22 situation, and the question is, what do we do about it? How can we get the best of both worlds? So this is where the concept of CORS comes in. Cross-origin resource sharing is just a specification or a protocol that is an extension of the HTTP protocol to enable a controlled way for scripts from other sources to be able to interact with servers. So it's the server controlling the access to itself by dictating certain terms and conditions, and the browser is collaborating with the server to enforce these terms and conditions. So basically, that's the recap. And now we're going to go into a demo to see what this looks like in practice. Okay, so I want us to create, you can go to Spring Initializer create a Spring Boot application. So basically, I usually use Gradle with Groovy or Kotlin, Java, Spring Boot 3.11. So I use my own website as the group name. Artifact, maybe you can say CORS demo, and yeah, the rest is okay. Java 17. So I think the only dependency you would add here is Spring Web, right? And then you can generate this project and open it in your local ID. I use IntelliJ, but again, I've already like created this. We're going to see what I've created. It's really basic. I've not done much to it, and I won't waste time because the building time and all will take um, time, which is precious for us. So then, for React, I use npx. Ignore all that other stuff. So you can use npx create React app, and you have it will be created. But again, this can take some time, so I'm not going to dive into it. But you can create it, and now I'll show you the apps I've created. So I have my Spring Boot application here, and you can see I've not really done much to it. Basically, apart from the controllers package, I've not added anything to it. And if you check the resources, the static folder is empty, templates is empty, all default settings, application of properties is empty, and I created a controller. What does this controller do? It's just a REST controller. It has one method, get method, and at this path. And basically, what it does is just to return these words. And then moving on to the React application. If you've worked with React before, then you'll see that this is just a very basic setup. The initial setup of create React app. So there's nothing I've added here. And for Spring Boot, you could check my dependencies and really confirm that I just have Spring Boot web, starter web. That's it. And then for for React, the package.json has literally no dependencies. So just the React basic dependencies. So here, we can start this Spring Boot application. And okay, so it has started very quickly. It's running on port 8080, and if I go to my browser and I type localhost 8080, that path API slash CORS. Basically, this is the response I get, just a string, and very basic, no complication. We're interested in only the communication between. We don't want any fancy features on the server. And then coming to the React application, I can start it. So npm start, and I really wanted to make sure these things build fast, so we don't have to waste time with. Okay, we don't have to waste time waiting for things to build. Oh, okay, ignore those. It compiled successfully. So if I open the React app here, right. So here is our React application. Everything good and smart. Wow. So let's open our dev console, because we're devs, we're going to spend most of our time in the console, and any errors I want to show you are going to happen on the console. So a recap, I have a server, a Spring Boot service, which basically just serves one thing, this string at one API path, okay, one endpoint. And the React application, just sorry, just basic stuff, and it does nothing really. So if I load that, everything good. So what I'm going to do is to add some code here to send a request to the server when this page starts up. So how do I do that? I also have some code I have written over here. I'm going to just paste it in a bit. I don't want to waste time with the code, but all I need is a request to that server. Any request, a GET request. So if you look at my what I've pasted here, basically I've created some state object called I'm using React hooks. They use state hook and they use effect hook. So use state just keeps the state of the page. I have a state variable here called CORS resps, and it's going to store the response we get from the server. And then the set CORS resp is the method I'll call to set its value. And if you know React, then every time I set this value, the page will render. And I want to this, and in the use effect, I am using the fetch API to call our endpoint at localhost port 8080 API calls, just the same way we did on the browser here. And we expect this value to be returned after the promise resolves. So I'm printing the response here and then converting it to text and resolving that again, printing the text here and setting the course variable, setting the state variable, course resp. So this value will get the value the API returns, which is this. And I'll set it. And where do I use this? I'm going to use it. So instead of using create React application here, which is what is displayed down here, I want to display the text I've got from the server. So let's just do post resp over there. And in my chain of callbacks, I've added an error handler. It will catch any error that comes and logs to the console. So all these logs are going to help us to you're going to see anyway. So I'm going to explain why we need them. So let me save that. Well, it has re-rendered. So don't be surprised when you see a lot of stuff on the console. I'll explain it. So basically, I'm on the network tab of the React application. So here, our text has not displayed. Remember, we replaced create React application with the state variable, which we populated with the response from the server. So if you look at the network tab, you're going to see that we have requests to the CORS API, and they are all ending in error. Status is error. Okay, so what has happened? Let's open this one request. The response tab here is open, but there is no response, right? Let's just make observations. There is no response. If I come to preview, there's nothing. If I open the headers, now wait, something interesting. Okay, this is the URL that was called, but it's a GET request. Status code is 200. It's green. This is a success status, as we saw earlier in the HTTP anatomy in the previous chapter. Okay, so if it's 200, then why are we having error? All right, why is the log in the network tab red? So let's first go down to the request headers. Okay, all right. So if you look at the headers, I talked about a couple of these. In again, this is why it was very important for us to go through the anatomy of an HTTP data exchange. So now we can understand what we're seeing. So you can take a look at some of these headers. I believe many of them look familiar to you, like accept encoding, accept language, cache control. We looked at these: connection keep alive. Do you remember host? Yeah, here it is. So our API is post 8080 slash API dot slash course, but here it's just the host as we discussed. So it's just the root URL of the host that we are calling the backend server that we are invoking. Then finally, our origin header is here. So this is This is the most basic way the browser enforces the CORS policy. So what it does is basically, remember we said that the CORS is a browser is an HTTP header based policy that extends the HTTP protocol. So the extension point we said is the HTTP headers, and we mentioned that the origin header is the first and the most fundamental. So any CORS compliant browser will attach this header by default for every request that it detects is cross origin. So this marks the beginning of enforcement of cross origin resource sharing. So the browser is adding the origin of the script that is running within itself and is sending a request to the server. So the server is supposed to use this to decide to tell the browser, okay, all right, if this request is coming from this origin, then I don't allow or I allow. Remember, the CORS policy helps the server to control, to relax the same origin policy in a controlled manner while allowing scripts to call it and at the same time protecting itself. So, what the server would typically do is to either accept this origin or reject it. Do you see that? All right, so we've looked at the header for our request. Now, let's look at the response headers. So, remember, the browser has added this origin and it's expecting a response from the server. Mhm. So when you look at all, good enough, the response headers are few, they're about five. So when you look at each of these, I think you can tell what each one is doing from our previous chapter. So we can't see any custom header here. Remember, we said that the server responds with headers as well. They communicate with the client using headers. We can't see any header here that deals with cross origin resource sharing. So, as we also saw our server, it's not enabled in any way. It's just a default setup of Spring Boot with one controller method. It doesn't have any capability to manage cross origin resource sharing. So, what's the default method? It sends nothing. And when it sends nothing, the browser defaults to a backup mechanism, which means that block anything. So what we're seeing is the browser has basically blocked our request from the script, from the React script to the server. All right, so we've looked at this is the same. I think it was a retry or something like that. So now you'll get answers from the console and network tab. Let's open the console. Ooh, so what do you see? All right, so we have an error printed on the console. Remember, in the React app, we have these console logs to help us understand what's happening in the application, the React application. So the first one logs the response when it's successful, converts it to text, and then we log the text. And if there's an error, we log the error. So let's see what has been logged. First, ignore the red, the errors thrown by the browser. So you can see none of our logs was shown on the console, right? Only the error log. So an error was indeed caught. So if we look at the error, cause error code, well, it doesn't tell us much. This is a React interpretation of the error. But then I just wanted to point out that the error control flow was called. But let's now focus on the error thrown by the browser. So let's read it. Access to fetch at HTTP, blah, 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 8080 API calls, basically our API endpoint from origin this, which is our React application, localhost 3000, has been blocked by CORS policy. Why? No access control allow origin header is present on the requested resource. Hmm. If an opaque response serves your needs, set the request mode to no calls to fetch the resource with calls disabled. So basically, this is what will happen every time a script tries to invoke a service that doesn't allow calls from scripts that are that are violating the CORS policy. This is the most basic error, and I think this error is very common. And if you Google this, you will see so many results on Google. But for our case, I want us to focus specifically on. So we've understood the first paragraph. Uh, so in this era, the browser is recommending two approaches to get from this point to the next point to try to resolve this error. One suggestion is implicit. It's not really an explicit suggestion that do this. So it says it states that no access control allow origin header is present. Remember, we said the browser did its part and sent the origin header to the server. It expected communication, but so it's like asking the server, okay, look, this request is coming from origin localhost 3000. Tell me if I should let it invoke you. Then the server is supposed to respond with a header. The browser has told us the header it was expecting from the server. It's called access control allow origin. So this is another header of the CORS policy that the server is supposed to send to the browser. And in this header, the server is supposed to tell the browser, I accept this or I don't accept this request from a script from this origin you've sent me. Then the browser will know what to do. But in the absence of that header, the browser simply blocks the request. Okay, so one approach to resolve this is to properly set up the server to send its instructions to the browser so that the browser knows what to do, either to accept or reject. And then the second option, like I mentioned, is to disable. So the browser says that if an opaque response serves your needs, set the request mode to no CORS. So if we go back to our highlights here, we did a recap. We were doing the demo, and I mentioned that there are going to be two ways we'll get from the errors. One of them is disabling CORS, and another is accepting. Okay, opaque responses. They're really just related. So disabling CORS is basically the suggestion that came from the browser's error. So this is where we are. I hope this makes sense. So what are we going to do now? We're going to try to disable CORS in the client application. How do we do that? So it so happens that the Fetch API, which is a really popular way for client applications, Angular, React to interact with servers, like their HTTP client of choice, apart from others like Axios. But Fetch is like the more mainstream and the more trusted one. So we can add another field here, header. It's going to be a header. And I want to just remind you that if you look at the request headers here, there's another header here, sec fetch mode. So fetch mode is just should we use CORS or no CORS? And by default, the browser defaults to enabling CORS. But we can disable this. It will show no CORS based on what we're going to configure. So here, let me clear the network logs. Let me clear the console logs. So here I'm going to add where all right. So mod it's even auto completing. So no CORS. So I've added a mod and save. Unfortunately, I can't put the screen side by side, but if we go back, let's start from the network tab. Now the reds have disappeared. The errors have disappeared. Why? Because the browser's default behavior is to block CORS requests. So the default behavior is to enable CORS, to have CORS enabled, and block any request that is cross origin, as we saw earlier. But now we've said no CORS. Now what has happened? If we open here, status is still 200. If we go to the request headers, everything else is the same, but this fetch mode has changed from CORS to no CORS. So we've disabled CORS. That's why the browser is no longer throwing errors. And that's why I said that's a risky way of getting around this problem. Reason being, we've disabled CORS, but it doesn't mean that by disabling it, everything is going to work as expected. As you can see, we've not received our text we expected. All right, we expected CORS. What did we expect? CORS success. We expected it to be printed here, but we've not seen it. we disabled CORS. So if you don't understand CORS and you're troubleshooting this problem, you might not really land on it in without doing a lot of back and forth and having to Google a lot. So uh, let's now go to the console. Again, no errors, okay? Because we disabled CORS, so we've disabled the default security mechanism. And what is the feedback? So remember, I made some logs here to show us what is coming from the server. I wanted to log the response from the server and also log the text itself. And this time, if there's an error, log it. But this time we don't have an error. Instead, our texts are printed. Response received, response text. Response received, response text. But they are empty. The response text is empty. All right. But if we check from here, the server is actually sending a response. And even in the React app, if you look at the response object itself, there is one keyword you should notice. The word opaque is there. Remember, we said that we're going to disable CORS, and then we're going to talk about opaque responses. So coming back here, this is now the side effect of disabling CORS. So another thing I want to show you is that if you go to the network tab and open this request and you check the response, initially, actually our response is here, CORS success from the server. All right. Initially, it was empty when CORS was on and the browser was doing its default behavior of blocking requests. This was empty, but now we receive a response in the browser. But then in the console, the script cannot log it. Our script is trying to log, but it's getting opaque and undefined. So, what is happening here? Let me explain. It so happens that when you try to bypass the security mechanism by disabling CORS on the browser says, okay, so you failed to pass course and you decided to disable it. So what I'm going to do, I'll send your request successfully, but when the response is returned, the browser will have it, as we've seen here. The browser has access to the response, but the script, which is the client running in the browser, doesn't have access to the response. So the response is opaque to the browser, to the script running in the browser, and as a result, I can't access the text inside, so I can't print what I wanted on the page. So what has happened? I've been denied access to the critical information. You remember, you send a GET request to fetch information from the server. This could be a list of users or a list of maybe countries, whatever the service is providing. But now the script cannot access it, so it can't render to the user. Okay, it can't. So there's nothing that is happening. Okay, so the fact that I disabled CORS, the browser kicked in another mechanism to still protect the server from unwarranted access from third-party scripts, right? So having seen that, and I want to bring another edge case that I thought about while preparing this. Okay, just a minute. All right. So what I wanted to say is that you might disable CORS in some special cases. Maybe you don't really need the response. You don't need to inspect the response from the server. You're okay with an opaque response. So when you have that, you don't really care. If that's your case, then you can disable CORS. But if you care about the response, then you need to go through the trouble to set up CORS in a good way, in an acceptable manner. And an edge case I thought about that I mentioned is that someone may think, okay, this is a GET request, which leaves no changes on the server. What if it was a POST request, which actually posts some data to the server to save or to manipulate, or a put request or a delete? Are you telling me that the server would get a status 200 here, a status 200 here, which would mean that the server has executed the action I sent to it? But still, on the client side, I would still not be shown the response. I would still get an opaque response. You get the validity of the question is that if it was successful, then the third party script would have manipulated the server. and as a result, get back a response, still block the client from displaying the results, but it will have manipulated the server. And the answer is no. CORS um, is exhaustive enough to take care of all those. And we're going to see in a few lectures what really happens when you change the request mode. So a GET request is safe, just like it's safe in REST APIs generally. We know that there will be no permanent change on the server. So CORS is also adapting, moving in tandem with the HTTP specification and other API, conventions. So a GET request is detected as safe, so the browser goes ahead to send. But if it was a POST request or a delete or a put, then the browser would add some other mechanisms, and we're going to learn it in the future chapter here. And basically, this is the end of our demo, and I hope you've learned something because now, to recap, we went through the definition of course again, and we listed. Let's just go through this thing. So we recapped the course policy, and then we did the demo. In the demo, we got to see a, an actual cross origin request. We looked at how the origin header is added, and we discussed that it's the most basic form of the browser carrying out its mandate of enforcing CORS. And after looking at the origin header, we looked at the response from the server, and we could tell that the server was not responding in a course compliant manner. So the browser, having received no specific response from the server, kicked in the default mechanism of blocking the request. And then we looked at the error, and we saw two options the browser error gave us. One of the options was disabling CORS, the other one was accepting opaque responses. So basically, we attempted to disable CORS, and we've seen the side effect. All right, we get an opaque response. We can't access it in our script. So basically, if that's what we needed, then we are done. We need to go ahead and set up CORS properly. And if that's not the case, and we decide to do with opaque responses, then we've also seen the result of that. And basically, what I'm doing now is giving the summary. And this brings us to the end of this chapter. And I hope you've learned at least the first step practically in terms of how CORS actually works in a client server interaction. So, in the next chapter, I'm going to dive into another. So, in the next chapter, we're going to go to the server side of things. We have looked at the client side, very basic setup. Then, in the next chapter, we're going to go to the server side and also try to make the server course compliant, but only in a very small incremental step so that we can digest these concepts very well. So, thank you very much. I'll see you in the next chapter. Cheers.